What do you say to somebody when they say, can you dumb it down for me? I want to get your take. I'll give you my take if you're interested.
Yeah, I really hate that phrase, dumb it down. Because I think what a science communicator you're trying to do is to not remove any of the complexity of the topic or whatever. It's just that you're trying to get it across in a way that someone will understand, right? Like, you can take sort of like Einstein's theory of relativity, and you could communicate between astrophysicists and being like, here's what it means, just by giving them an equation, and like someone would understand that, because that's a language they're used to, right? Is the language of maths and tensors and vectors and all that kind of stuff you learn, and if you do a degree in physics. But if you come across like, you know, Joe Jane public on the street, you're not gonna like give them an equation, but you're not dumbing it down by expressing that in different words at the same time, right? And so that's what I try and do is still keep the level of complexity, and like if I need, I'll build it up with you know, the concepts that you need underlying that, but again in like the simplest way I can. And I've always, in the back of my mind, I've always got my mum, right? My mum is like, you know, she did high school,
3 PhDs in astrophysics, and she's a relativistic particle physicist.
No, so she did high school and then left at sort of 16, which is the age you can leave high school in the UK, and that was it. But she's always been like interested and intelligent, but never educated, right? Because there's a difference between intelligence and educated, right? And I always think as long as my mum would understand what I'm saying. And I love the fact that, you know, for those who don't necessarily have the night sky that they can enjoy, or for those who really do get so captivated by these questions and want to get involved themselves, citizen science is a way for them to do that, you know. Okay, necessarily sort of going out in the garden, observing with your telescope every night, trying to discover an asteroid, because I think sometimes that is what drives people, that sort of desire to discover something. But the idea that, you know, I need help doing my PhD, but there's so much data that, you know, me and my colleagues, there physically isn't enough of us to go through it all. And so, you know, the idea that 300,000 people around the world could help you with your PhD is incredible. And so I always, you know, sort of laud citizen science whenever I can, because, you know, I've written papers where there's me and maybe like 8 collaborators from Oxford, Nottingham, you know, Chicago, Minnesota, you know, wherever in the world, Sydney or something like that. And then 300,000 other people, you know. And it's like, this work would not be possible because all of these people went to a website, they saw an image of a galaxy, and they were asked, is it spiral shaped or is it round and blobbish? Which is such an easy question, you know, because image recognition is one of those things we can do from like a toddler, right? It's one of those things that we learn as children. And so getting people involved in that kind of science with the knowledge that, you know, this science and this result and this discovery, you know, wouldn't be possible without them, I think is incredible. And there's a great story out of the back of one of the projects. So one of the projects was asking people to look through planet data and the Kepler Space Telescope data. And it was basically sort of like, we're looking at stars, and if the star's brightness dips, there might be a planet there. So can you record for us if the brightness is dipping anywhere? And it was such a great project, and so many people got involved. The idea that you could discover a planet, you know, around another star in our Milky Way, that was obviously, people absolutely loved that. And there did end up being someone who had discovered a planet that like computer algorithms had missed in the data. And he was a guy from the northeast of England, retired guy, and the media descended on his house, right? And we're like, why did you get involved in this like incredible project? Like, what was it? Was it the discovery that like drove you to do this? And he was like, well, there's only so much gardening you can do, and there's just not a lot on telly lately. Like, you know, and it was just this retired guy, and they were like, do you think you've caught the bug? Do you want to catch another one? And he was like, no, probably not. I'll probably do something different now. To know that what I was spending my time doing was useful to someone somewhere, whether it was, you know, classifying the shapes of galaxies or the shapes of craters on Mars, or flagging where there are penguins in images from Antarctica. You know, there's these huge raft of different citizen science projects, and it's a tool to get people into it, but it's also a tool to let them be involved in science themselves. When I finished my university undergrad, I was like so lost of what to do, right? I loved school and I felt bereft when I left school, right? And so when I got to university, I was like, phew, 4 years at least. Now I like this is fine. And then at the end of that 4 years, I was like bereft again, not knowing what to do, because I just love learning and just these holes of learning. I was just like, I want to do this for the rest of my life. And I didn't realize at the time that going into research meant you will still be learning for the rest of your life, right? Because you're not necessarily being taught it anymore. You're the one figuring out the answers. No one's telling you the answers anymore. You're literally like writing the textbooks.
It's not like solving harder homework problems, right?
Exactly, right, yeah.
It's problems that might not have an answer. I mean, you didn't know if you'd find this answer, these quenching questions until you actually did it.